Could you just confirm if you can see my screen? Anyone, if they can say a yes or no?
Yes.
Yeah, I can see it.
Cool. Okay, so good morning, everyone. Thank you for attending the bootcamp. I hope you all had a great start in the lectures yesterday. Today, I'll take ahead and start with hands-on exercises where we would be basically trying to run programs using Python. The structure would be different than yesterday's class. You don't need to worry about if you have a low performing system. You don't need to worry about that. The only need required to run codes would be a good internet connection. And if you are attending this call, I hope you are already having a good internet connection. So don't worry if you have a low performing system. I also believe everyone is now aware of the contents that would be covered in the bootcamp. And today, in that part, we'll continue with the introduction of Python programming. So a little bit about me. I am Nikhil Singh, a PhD student at Department of Civil Engineering at UTA. I've been a PhD student since 2021. And my main area of research is improving the energy efficiency of existing buildings. I personally have seen firsthand experience of how programming languages, specifically Python, can be used for analyzing big data within buildings and helping it. And by analyzing those data, I'm able to find different kind of energy inefficiencies. In fact, in my previous work, I have tried to use programming on a lot of buildings, so like a city level analysis. And as Dr. Jessica just mentioned yesterday, that there's a lot of difference in thermal comfort profiles within a building. So I have worked on those similar research areas today too. Today, I am excited to share with you my experience, and I'll be introducing Python to you all. To give a little more background, I'm not a civil engineer. I'm an electrical engineer. I did my bachelor's in electrical engineering. Thereafter, due to my interest in solar photovoltaics and energy efficiency, I shifted into the building, so applying electrical engineering principles within the building sector. So while looking at the profiles of the students, what I found out that some of you are not from the background of civil engineering or architectural engineering. So there is nothing to bother about. Even I am not a civil engineer or an architect or an architectural engineer. But there would be case studies which would be looking around those areas. But more or less, the concepts which I will be taking today will equip all of you with the foundational knowledge to start coding or to start programming by yourself. So I would like to start with giving credits to my teammates, the three professors which you see, Dr. Park, Dr. Raisma, and Dr. Chakravarti. All three of them have guided me to prepare this presentation, the contents of the presentation. Along with them, Junaid, who is also mentoring this session, has been very helpful to me in helping organize this presentation and understand my GeoHub specifically. Apart from Junaid, last year this project was conducted by Tenor, and I want to also give him credits because I've been utilizing a lot of his content that I'm presenting today. So before going ahead, I would like to share with you the objectives of today's lecture. So mainly there would be two main objectives. One, after this lecture, you'll be able to program by yourself. I expect that. By that, I mean I'm not expecting that you would be pro level or a pro max level kind of a coder. but somewhere between beginner and intermediate level of coding experience you would have. So that fear of initiation, that fear of starting with coding, I think that should be gone after the end of the presentation, because the main reason is we'll be performing a lot of hands-on exercises. Uh, the main contents of the today's lecture will help you in manipulating data. Uh, so using different kinds of functions within the Python that are available, use them and manipulate data, make decisions, and understand different kind of uh, flexibility that Python offers to use different kind of data tools. So it will give you a good idea of how to start with or how to approach a particular problem. I have divided this lecture into four parts. We'll begin with programming. So how is programming being applied in the domain of engineering? Next to that, we'll be, as I said, we'll be starting with the interactive exercises. I will be having a lot of to and fro interactive exercises. So I won't be bombarding with you all with theory and then at the end I'll go with the practical part. I'm not doing like that. Instead, I'll take a short theoretical. I'll explain a short theory and then we'll learn to apply. And similarly, we'll try to complete all the parts of the today's presentation. Later or finally, we'll go through some complex application of Python, which includes loops or conditional statements. Uh, those aspects would be very much useful for you when you start playing with the data. Mainly cleaning, understanding, analyzing different kind of data sets. And at the last, I leave you with a resource of uh, places where you can get your answers, because each of you may be working on a data set that is totally different, that is totally customized. So you won't get plain or similar answers, but definitely you'll get answers, or definitely you'll get to know about questions which are asked by people, and you can learn from those answers and basically adopt in your methods. So I'll leave you with a resource, a commonly used resource. I hope many of you may be knowing also, those who are aware about programming or who have done programs. But anyways, so let's begin with programming and engineering. I hope you all would be aware about NASA's Mars project. I think it was finished in 2018, if I'm not wrong. The NASA Spirit and the Opportunity rover that landed on Moon. Uh, uh, it clicked photos, sent back to us. Uh, it moved a little bit on Mars. I think they have a very beautiful graphic on their website where they compare different uh, kind of rovers sent by different countries, their years and how much miles or kilometers they have traveled. So it's an interesting graphic if you want to look for yourself. Uh, the thing is, how does programming here come into play? Uh, as I said earlier, it clicked pictures and sent back to us. That is where programming was involved. We remotely operated the rover on the Mars. So that operation, that automation within the operation, remote operation, was done using programming. I'm covering some famous programming applications. There are a lot of these programming applications that happen in and around us, but I'm covering just famous ones, and then we'll get back to specific engineering focused ones. The other two applications which are you're seeing on the right hand side of your screen is trading, or almost all of many of you would be aware about what trading is. So there are some trading applications these days who predict the cost of the or the rate price of the stocks. So they forecast those prices. So that specifically that process is called algorithmic trading. So again, wherever algorithms are involved, directly or indirectly, programming is involved. And lastly, about Amazon recommendation engine. So we can't limit ourselves to Amazon recommendation engine. Other different example could be a YouTube video recommendation, where you interact with YouTube by opening a Google account, accessing it through a Google account or a Gmail account. You provide YouTube with some information. They get the metadata of your. They put your metadata into a certain archetype and send you certain kind of videos. It could be according to age, it could be according to gender, it could be based on what you are searching on YouTube. Similarly, there are, in fact, not only YouTube, a lot of social media applications these days apply these automated recommendation engines. So all of these engines use programming. So what I mean to say is, on a day-to-day basis, we use several search engines that are based on programs that basically help in optimizing our search results. There are some negative aspects of that too, and there are a lot of good Netflix movies on that, that how programming is controlling the mind of the human. So you can look about that too if you're interested. But there are good case studies too. So coming to engineering applications, has any one of you seen that video of Baltimore Bridge? What do you say? Collapse of the Baltimore Bridge that happened. That's on the left side of the image. So it was a news, I think, a big news around the world 2 to 3 weeks back, where a ship collided with the bridge and the bridge collapsed. So unfortunately, there were 4 workers working on the bridge that died due to collapse. But this incident was in news around the world. It stopped all the trades that were happening across that harbor or across that coastal belt. So there's a huge economic impact, huge financial loss, both in terms of trading materials, stocks, and at the same time, the traffic is also affected because it's one of the main lines for the ships to reach the harbor. The thing is, why I brought in here is recently, like about 2 or 3 days before, as you see in the picture, there's some part of the bridge that still remained on the ship. Ship was fine. As per the experts, they say that ship can be docked back to the harbor. But some parts of the bridge fell on the ship actually. So what they're trying to do is, in the picture is they have done a controlled demolition of the bridge so that they can remove the debris according to the plan which they have made, and then they can move the ship back to the dock. And since they have made it controlled, there would be less loss of lives or habitat in and around that part of the ocean. The main point here which I want to highlight is, if you see that term controlled demolition. So there are softwares or there are software programs which are written just to simulate those kind of demolition exercises. So you would have seen a lot of buildings which are demolished in a controlled way. So that too in a way that they don't affect any kind of habitat in and around them. But this controlled demolition was tough because it happened in the middle of ocean, and they instead of humans this time, the sufferers were different. So the main point here is there are simulation softwares which you can use to make custom scenarios or simulate custom cases to find out how you can demolish a particular structure. So by this, what we can learn is within the domain of civil engineering, there are several applications when it comes to simulating a scenario. Although these programs could be developed in a certain language, all of them, mostly the famous ones, offer some kind of scripting where you can create your own custom cases. So based on these custom cases, you can enhance interaction of one tool with another and test design iterations to provide solutions that would be resilient in the future. So just like that Baltimore bridge control demolition picture, the next two pictures are just snips of the Autodesk Revit design software and wind simulation software called as ANSYS. Those who are civil engineers or architectural engineers already know what is the capability of Revit. Those who don't know, I just want to let you know that you can basically create 2D or 3D models of your buildings or any infrastructure project which you are working on. You can create virtual models, again, create scenarios, test them, and understand how your building or infrastructure is performing. The third picture, again, as I said, simulation. How does your building perform when it faces a different kind of wind velocity? How will it perform during a tornado? Or how will it perform during a hurricane? Which facades will be affected? What would be the thermographic profile of that particular building? So there are a lot of different cases which you can analyze. Programming gives you that ability and flexibility to custom make your scenarios and test them. So, as I said, there are a lot of applications of civil engineering, but there are a lot of applications of programming in civil engineering, but there are some specialized use cases also. Earlier, as I talked about one of the studies where I myself modeled 900 buildings of a central business district and tried to, and that part of those buildings which you see are on the left hand side. This is where I'm trying to model different kinds of buildings and how they will perform or what would be their energy efficiency, how much energy can be saved if the buildings are if the buildings that are not constructed today but are constructed in 2050. So how the energy profile will change, what kind of building types would be increasing. So you can create a number of combinations. This is what I did. I used machine learning to find optimal energy conservation measures. And I found that, and those are the results. Similarly, on the right-hand side, somebody tried to look for water supply contaminants and predict them. So these are very specialized use cases in the domain of civil engineering, where you can create, again, as I said before, where you can create your own scenarios or custom cases, test them and analyze results. The question would be, when you create these custom scenarios or test them, how do you validate them? So again, programming offers or provides or comes up with several packages of statistics, of machine learning algorithms, where you can create a certain set of your data, test it with today's situation, and on the basis of that, you develop situations or cases for the future. Since it's very difficult to validate something in future, what we can do at Max is we can create multiple scenarios. This is how the Paris Climate Agreement also works. They say that you have to reduce or you don't have to let the Earth's temperature increase by 1.5 degrees Celsius. So how did they came to that number? So they used several number of climate models and tried to predict how would the temperature of the Earth change till 2050. I don't have right now in my slide, but if any one of you want to look at how many number of climate models in the world they have tried and come up with that number 1.5, you could go on the World Bank's website, and they have a interactive website where they have listed different number of models that have been used. So now we got a little glimpse about the application of data science within the field of engineering and specifically within the field of civil engineering. Let's shift our gears and try to understand how we can approach or create these problems. Solve these problems. Little bit historical context, and then we'll be moving ahead with programming or in Python, using Python, sorry. So how did we interface with computers? I think almost all of you saw Dr. Chakravarti's picture yesterday, where he showed a 4K system back in 1960s and how huge it was. So I don't have that, but I'm trying to show you how humans have been interacting with the computers. I'm a little bit ahead than Dr. Chakravarti. So around 1990s, we users entered commands in operating systems to perform operations. After that, there was a lot of development and graphical user interfaces were developed. We have several programs. Right now, I am interacting with Teams interface to show you, to present you the contents of the Python. This itself is a development which did not happen earlier, so our interface with the computers changed. In fact, today, I think with Apple's Vision Pro, the latest one, the interaction has completely changed. Now you don't need a physical system in front of you. You can interact with a very little or very small size equipment and perform your day-to-day applications. So VR and AR, virtual reality and augmented reality, are few good examples of how the interface has changed. So as I said earlier, that there are several programs, interface programs that have been developed to, for example, having video calls. That was done using Skype. Performing mathematical operations, creating databases. That is today done using MS Excel, mostly. There are alternates to that, but primarily MS Excel is widely used. Then the interaction with the video. Earlier we had, if you remember, there was a video player called as VLC media player that was very famous, where we used to run our MP4 files or other kind of different files. So this is how we interacted with computer earlier. And since these are nothing but the interaction within the computer was done mainly by developing programs. So different kind of programming examples you see on your screen. Now the question is, how were these made? So these were made using computer programs. What are computer programs? These are the languages, or basically rules and grammars that computer understand. They follow a certain syntax. That is how these were made. And then that syntax can be interpreted by the system. There are several programming languages. Some have a syntax using which the code can be interpreted faster. For example, C, C++. Some takes a much longer time to get interpreted. The difference is C could be interpreted well by system, but it's very hard for the user to learn. So it has a very steep learning curve. Whereas Python may take a little more time to get interpreted by the machine or the computer, but it has a very easy learning curve. It's more or less similar to learning a natural language, not exactly natural language, but the interaction but the learning of the programs become easier just because of the nature of the syntax used in the Python programs. Going ahead, I have already now gave you a gist of what are engineering programs, how they are applied, how did we interface with the programs, what interfaces have been developed today to solve our problems. Now I'll be going ahead straight away to our navigation or path to learning Python. So the question is, there are n number of languages: Java, C++, Ruby, JavaScript, Python. The question always comes into mind, and it also came in my mind which language to start with? So to answer this question, it depends on your use case. For example, if you are working on a research project where you want to host a software that can be used by multiple people, you need to create a website, or if you want to host on web, so you need to create a website. So to do that, you will be using either a JavaScript or a PHP. These are some famous programming languages that are used to do that. In case if you are looking to develop a mobile application, maybe a game, you need to start learning Kotlin. Some little bit of Java could also help, but if you're working on Android application, Kotlin helps a lot. So again, if there is mobile app development, you go with these languages. Then comes C, C++. As I said earlier, C++, C are the languages that do multiple kind of stuffs, but they're hard to learn. Still, even if they're hard to learn, the interpretation of these languages by the systems, where mainly the execution part comes into play, that becomes very fast with these languages. But the question is, then why Python? Python these days does a lot of different kind of jobs. It can be used uh, to create websites. It can be used to create databases. It can be used to create mobile applications. Along with that, it has inbuilt or pre-built packages that can be used for data analysis and visualization. In fact, lot of packages or libraries for machine learning is also available in Python. What I mean to say that there are a lot of things which you can do in Python. Now, why Python and what are the reasons of using Python? I'll be covering in more detail, and how does it compare with other languages? I'll be talking about that. So Python, first of all, Python is very simple to use, as I said earlier. It's very near to uh, a natural language. The interpretation is much faster compared to some other languages. Uh, the other important point that Python offers, the advantage that Python offers, is that it's available for a lot of different operating systems. So you can use it on Mac, you can use it on Linux, you can use it on Windows. So there are if there are other operating systems, uh, there are a lot of details how you can install Python and run on those operating systems too. The it's called a high-level language, and the reason is that it offers high-level data build types such as flexible arrays and dictionaries. So what I mean by that is just like how we learned in mathematics about matrices, we can create a data set uh, or a data frame or a data framework, just like we do in Excel. And since Excel performing operations on an Excel column or a row becomes very easy, Python has a similar capability. It allows us to perform operations using a similar approach. Python also allows us to split our programs in modules. By that, uh, some programming languages, if you write a code, you need to run all of them at once to get some kind of output. Whereas in Python, you can write code in chunks and you can execute however you like. So if you want to execute any part of the code, you can just execute that, run that, look at the output. The best advantage is you can copy that particular section of the code or chunk of the code and use it for some other analysis. That's a very beautiful advantage that Python offers. And two other main reasons is it's extremely popular. And since it's popular, there are a lot of libraries available online for several use cases. Recently, I used Python and applied a large language model to my data set. So we were discussing about ChatGPT yesterday. One of the attendees discussed about that. I myself used an open source large language model library, which is available free on web on Hugging Face portal if anyone is interested. So you can go on that website, adopt that model, apply to your data set and look at the results. You can do on your local systems. When you interact with ChatGPT or any of such kinds of applications, you share certain amount of data with them. Your interaction is kept on servers, and if you don't make changes in the privacy, your data is being used to train their models. So when you know Python, you don't need to bother about the privacy aspect when you are interacting with any large language model. So this could be done by other programming languages too, but since it has a very wide community, these libraries or packages are vast and widely available. So before going ahead, do you have any questions still here as to why we are looking at Python? Okay, so a little bit about Python when it was developed. It was conceived in late 80s and was influenced by many languages that time. Like Perl. Perl is one of the famous one where the Python uh, based on which Python was conceived. As I said earlier, uh, it it has a particular syntax. You have certain advantages of reading the code, uh, which is similar to a natural language, not completely, but most of the aspects is similar to a natural language that emphasizes or that increases the readability of the code. On the syntax part, it follows very simple convention of indentation, which is very easy to adopt and learn and apply in our own cases. And it's object oriented. That means you don't need to type the names of the variables. And we'll learn about that in the interactive exercises, how to do that. And as I said earlier, it's one of the most popular languages in the world. And in fact, I read a research paper some time back where they did data analysis of where they were trying to investigate which language you should learn if you are a beginner and which language you should learn if you are an intermediate or a pro level programmer. So what I found out by reading that paper also, that after C and Java, the most popular language in the world was Python. So these are some of the reasons why we'll be going ahead with Python and learning about it. And Python is available open source. You can download it. You can just type Python and it will take to the website. There is availability about you'll get the installation package based on your operating system. You can download that, install that, and then just start programming using Python. What I believe is many people ask me how to learn coding or how to learn programming. The best answer to that is just to start programming. That's the only way you could learn. Uh, it's difficult to look at. It's very difficult when you look at n number of videos and try to adopt that and start programming. It becomes very difficult like that. I have tried and tested that. For me, I just started when I was not able to adopt through those processes. I went ahead, learned the concept, applied that, made a lot of iterations, check what is the output, or how's the variation in the output, look at the errors, learn from that, and then go ahead. So in today's lecture, we would be using Jupyter Notebook to run Python codes. Jupyter, little bit about Jupyter, although it's not mentioned on the slide, but I'm just informing you guys. It was started as a project, research project, and now it has expanded into Jupyter Labs and Jupyter Notebooks. You can directly again go onto the Jupyter website, download from there, or there is a famous application called as Anaconda, which has a lot of pre-built applications inside that. It's again open source, freely available. You can go and download that. And from both of these places, you can access Jupyter Notebook. There are a few reasons why we'll be using Jupyter Notebook, and I'll be telling you about that. Normally, when we download Python, we get a Python idle environment, IDE. It also uses Python syntax and performs applications relevant to Python. But the difference is Jupyter Notebook is shareable document. You can combine lots of codes as plain language descriptions. So for example, many of you may not be understanding what is Python, what is syntax, how to run a particular code, or how to run a particular chunk of the code. What Jupyter offers, what Notebook offers is you can write the description of the code right at the start of before the cell where the code would be printed. So you will write the description, what it does. You can do those kind of stuffs with Jupyter Notebook. You can give a description to the code. And if you provide description, someone who has no idea what the code does can also understand and run codes on their own systems. And then it has flexibility of data visualization within it. So it can plot graphs, charts, figures for you. It comes with an editor. Since it comes with an editor, it itself becomes quite fast. Has a very good interactive environment. Again, I'll be showing you that in the upcoming slides. The code could be edited within the browser. So if there is an error or if there is a syntax, it will automatically be highlighted. If there is an error, it will show you what's the error. It will inform you what's the error. It will inform you at which line you are getting error. It follows a convention of indentation. And today we will be accessing Jupyter Notebook through the MyGeoHub platform, where it has its own version of Python, and we will be using that for running our codes. The last part would be that you can, if somebody is familiar with Chrome, they can launch Jupyter on Chrome. If somebody wants to do on Internet Explorer, they can do on that. And or if you are interested in whichever browser you want to use, so it runs mainly on browser. So you have the access or you have the control within yourself to launch a Jupyter Notebook in whichever operating system you want to. So going ahead and how to navigate Jupyter. So the screen looks a little bit like that. It's similar to a file explorer or a file directory. So before going ahead, just let me tell you some formats which could be exported from the Jupyter Notebook. So you have a flexibility of turning this Jupyter Notebook either into an HTML file, or if you're writing papers using LaTeX, you can convert into that. Or you can also convert the Jupyter Notebook in a PDF format. So again, it's an advantage also because with this, you can basically integrate. If you convert these files into those particular formats, you can integrate the files into other processes also. As I said, it opens in a web browser and you can have your own choice. The current dashboard which you see of a Jupyter Notebook, it again looks like a file directory. On the right hand side, the circle which you see, that is the place where you can click on new and you can launch a new notebook. You can, once you launch a new notebook, it will open a new file just adjacent to the file directory, which is open in your browser. And that is where you can start playing and running your codes. I think I have in my GeoHub, it opens like this, where you have uh, different options. Since we are conducting our or we are using Python, we'll be selecting Python 3 in our case. So make sure if you are not aware, you click on Python 3 while opening a new notebook. In case it's not opening, I think when you launch the notebook, it should by default, when you launch the notebook through my GeoHub, it should by default open a new notebook. I think you should not, it won't ask you to select Python 3. But if it asks, you can just select Python 3. So the button also provides a flexibility to create your own folder. So folder within your working folder you can create. So it works much like a file directory only. And you can also access command terminal by pressing the terminal button whenever needed. So if I have a chance, I'll show if you download a Jupyter notebook on your PC, how it would look and how you would interact with that. So this is how, when you click a new notebook, this is how the notebook looks. It would be looking similar whichever browser you are operating with. Uh, so it has mainly three different tabs, three different functions within its tabs. The main tab which you would be using a lot is called the toolbar tab, where you have several operations where you can save the notebook, add a particular cell. This is called a code cell where you will be putting your code. This is in means input. When you run the code, execute the code, it will give you an output. This is scissor. Scissor means if you want to remove a particular chunk of a code, you can use scissor. You can paste. I don't remember what this does, but if you can hover, it will show you. Simple like Excel or Word document. You can go up and down, run a particular cell. That means whenever you're done with writing a code, you can run that cell. You can stop if you are like using a very big algorithm or some kind of algorithm that is taking a lot of time to process. You can stop that particular section of the code. If you want to rerun or restart that code, if you want to run all the codes one at a time. I have these explanations later also, but this is a toolbar where you will be interacting a lot. This is menu bar, simple again, like other applications which you would have used. Important one is file, where you would be saving your files continuously, otherwise you will lose your progress. Kernel is an important one. Basically, kernel means is that the main job of the kernel is whenever you write a code and whenever you execute a code, it will send to the kernel. Kernel will work in the backend and then produce the result as an output. So a lot of times you will see that there would be, if you're running a code and if you get an error on the right hand side at the top, it would say that kernel slow or dead kernel or something like that, or restart the kernel. So that means you have to make changes with the kernel or refresh the kernel to run the codes. Finally, just like another file, Notebook also offers flexibility to write the name or rename the file as what you like. There's a convention if you could follow that would be very much helpful. I'll show you that because when you play with a lot of Jupyter files or when you call a lot of Jupyter files or different files in your code, it becomes easier to copy and paste and run with programs. OK, so going ahead. So there are these three hotkeys or shortcuts, I would say. So if you are on a Jupyter notebook and if you press B on your keyboard, it will basically create a new cell. Similarly, if you want to create a cell above your code, you can press A. And if you double press D, it will delete a particular cell. So the hotkeys become very much handy when you are working with. So that's what I said like earlier. that Python gives you flexibility to work in certain modules. So if you are a program and you want to do something else, for example, you were adding and now you want to do multiplication before addition, but you have already executed the to code. What you can do is you can go above the code, add a cell before the cell which performed an operation, write the code, write the program, and perform the operation. In the same way, you can use above and the delete commands also. Okay, now there are three types of code cells. So as I showed you in the Jupyter earlier, it was showing code here, which is by default you'll see every time. But then there are three major options. Heading is by your own. You can understand heading means writing the heading of that particular cell. Then there is markdown, and then there is raw NB convert. So what you see this black color here right now, this is a markdown, or this could be a heading also. You can specify it. So there are three types, as I said, markdown cells, cells, and raw cells. So a code cell will always allow you to edit and write a new code that it contains. You will have to use a code cell to execute or run a command. The results that are returned from this computation would be displayed in the notebook as cells output. So just like input, if you will be running the cell, you will be getting an output also. What do markdown cells do is they basically are used to document the computational process. As I said before, that it becomes easier if someone who doesn't understand the code and you share the description about the code, you could use markdown cells. You can add information. And the last one is the raw cells. So raw cells will provide you a place in which you can write your output directly. So while programming raw cells is not much of use because they are not evaluated by a notebook. But when you are integrating with other applications, then raw cells are useful. So, but in our case, or in our most cases, when we are working also, raw cells won't be much useful at this stage. So I would like to stop for a moment here. And if we could start our Jupyter notebooks. So I will ask everyone to go on the MyGeoHub website. There is an exercise there called as, I think I'll share the screen to tell you. Just give me a moment. So if you go on the MyGeoHub's website and click on the course offerings, within Tuesday, you will have a right button here. If you drop down this right button, there is a .ipynb file. This is the extension of Python files or the Jupyter Notebook files. So if you click that, it should open a new tab just adjacent to the MyGeoHub platform from where you accessed, and it should open a Jupyter Notebook for you. So I would like everyone to open the Jupyter Notebook in their local systems. Once you open the notebook, don't make edits. Just like what we have learned till now, just browse through them and check what they are. For example, saving, adding a cell. If it's a markdown, what other options are there? If I want to change like how it comes like that, just don't make any changes. Just hover around it and understand whatever we learned till now. Till everyone is with us on board and everyone has opened, we'll then go ahead with editing part also. Uh, So as I was saying that if you want to open a new notebook, if you click on File, if you click on New Notebook and select Python 3, I think it should open a new notebook on all of your systems as well. So just do that. You can do that also. You can edit like test file like that. Make yourself aware with the interface. So I'll wait for a few minutes, and if anyone is having any problem accessing these files, I don't want you to create a new file but for those ones who have already created, they can just create a new file and hover around testing the test file. But for the ones who are lagging behind, I would wait for some few minutes and like them to open this exercise notebook. So for those ones who have already opened, we have certain sections of the code. So a blue line which you see is a demarcation between different sections. So after each of the section, you'll see a blue line. So initially Python has a calculator, variables in Python, and once we finish variable, we'll have again a blue line. Then we'll be covering lists, certain operations on lists, creating a dictionary, playing with functions, going around packages, pandas, loops, and finally we'll be ending with a one conditional statement. Can you confirm if everyone has opened the files, or is there someone who is still facing any issues accessing those? If you can give me a thumbs up if like everyone is done, like 5-6 thumbs up would be more than enough. My GitHub allows one file at a time. If you are opening a second file, please terminate the session for the first file. Yes, I forgot to tell that. So once you don't need to open a new file, I told you just for the ones who were like behind. So if you want to, what you can do is simply terminate session and click on this terminate session on the right hand side. This will close this Jupyter file since we have to only work on one notebook today. I am facing some issues. Ankita says I am facing some issues. So Ankita, if you could let us know what are the issues you are facing. So if you see, it gave me a connection failed because I was trying. The notebook will continue trying to reconnect, check your network connection. So it may show you like that. Just click OK and it would refresh again. See, connecting to kernel. As I said, kernel is something which works in the backend of the Jupyter notebook, and its status will change once the Python is loaded. Okay, till Ankita tries, I have 2-3 slides remaining of the navigation. Let me quickly complete that, and then maybe we'll begin the coding aspect. Okay, so as I said, uh, in basically depicts output. When you execute a command, you'll see an output through this out. And each time, whenever you run a code, it will show you a number. So for example, if you run your code for the first time, it will start with 1, second code 2, 3, 4, like that. It will continue. So that helps to basically keep us track at what section we left at what section we were working when we were editing the code last time, till when the code has run successfully, or find out whether the code has failed at a particular chunk or a particular part. So a shortcut. So one way to run a command is on the Jupyter notebook. There is a run command. So if you click that, it will basically run that particular section of the code. Or the other option is if you click in the code cell and select Shift plus Enter, it would run the code. So once you run the code, it basically does the same job, the run command and the Shift plus Enter command. They're essentially same. So we already discussed, but for those ones who missed, if you want to terminate a session, you go on the right hand side of the Jupyter Notebook, click on terminate session, and it will basically close the Jupyter Notebook. So this happens in MyGeo Hub. When you locally install your Jupyter Notebook, it should not be like that. It will allow you a different way to close. So some basics before we start the programming. Programming mainly is the act of giving. We are not computer scientists. We are learning programs to solve our custom problems or custom cases, or to perform automation. So we can adopt knowledge from anywhere. We perform the general way is to perform the code sequentially, so one after the other. So from top to down or from left to right. That is how the code convention works. Generally, it is preferred that we operate through a sequential order. Although there are some slight caveats to it, but that comes when you are using like a very complex program while running with the Jupyter Notebook. The thing is, since Jupyter Notebook is locally installed, so not right now, but if you have your own Jupyter application running in your own system, and if your system is not that good in terms of RAM or CPU performance, it may sometimes not show you results that you expect. It may get dead. It basically gets dead, or it may take abundant time to run to execute a code. So as I said, we are not computer scientists. We will be adopting or borrowing ideas. If you have any code or application that can make sense, feel free to adapt that. There are platforms like medium.com, there are platforms, there are there are communities on X, there are communities on Reddit, which could help you with certain issues directly or indirectly, and they're quite responsive. So you can go on those websites, ask for your problems, and adapt the solutions they offer. Try and test them. I use them a lot. There are not so there is no Jupyter is like an open source project. So if there's no customer care kind of facility available, so you can contact them and ask for questions. So you can't do that. That's the problem. So for that, but there are a lot of open online communities which you can go access, be part of, and ask your question. I like to keep code as simple as possible because it makes so when I come back after some months or after years to that code back, I can basically understand what the code is doing. So if you try to do that, it will be helpful for you in the later aspects. If you organize them, describe them properly, inform the code what is happening, then it will be again helpful for you to understand the code later whenever you're coming back. So you can, read this book, Zen of Python. It will help you in understanding some clean habits of writing programs. So how do you maintain that? How do you share programs within your peers, or how to professionally program? And that will help you in your future careers. OK, so let's now begin with programming. I have a slide before that too. So and I'll get over this quickly. So program, as we discussed that programs follows a syntax. What is a syntax? Nothing but a grammar. Grammar that is interpretable by the computers. So computers will always do what we will tell it to do. But there is a difference of what you want to do and what you tell it to do. So these are two different things. A beautiful example is let's eat grandma. Let's eat grandma. So there you if you don't follow the syntax properly, you may not get the outputs what you're expecting. So I will take you through a lot of examples that can help you understand better about it. And we'll be going ahead with the exercises right now. So again, as everyone is having their Jupyter notebooks open, I think please go on that and we'll start the mathematical operations on the Jupyter notebook. I'll be sharing my slide. So I think if you refresh it, it will connect me back. I'll close this. So right now, just to tell you, it's the status is the kernel is not connected. So I'm trying to refresh it and I think the kernel should get connected. It's showing an error. Maybe I'll go back and open the Python file again. So this is the Jupyter notebook that we would be using today. Uh, Again, as I said, I've covered 5 topics. There's a reason why I have made this flow. We initiate with basics, learn some more complex concepts, and end with understanding functions and packages that would be useful for us in while dealing with large data sets. So I would like all of you to start coding the first program. In the first program, you are just trying to test Python, how it performs normal mathematical operations or basic mathematical operations. So you can go ahead in the cell and type those numbers and check what is the output. So if you put 27 space plus space 30, and you can run the code using 2 ways. Either you click the run command or you hit shift enter. So I'm using shift enter at my end. So as I explained before, input number 1, the first cell ran. It performed the mathematical operation of adding. Output, first output 57. So there are 2 ways of doing this. Now, if you remember, I showed you a shortcut of adding a new cell. So if you just click here on this cell, and if you type on keyboard B, you will have a new cell formed. And if you try to run a new code where I want to print a sum of 2 numbers, that is 27 plus 30, and if you hit shift enter, it basically prints the same result. So this is where Jupyter notebooks comes handy, where you can directly, instead of in a lot of programs or in a lot of environments where you use Python, you have to use print statements to print the outputs. But in Jupyter notebook, it just performs basic operations directly. So now, if you have understood this, go ahead and perform addition, subtraction, multiplication, and division. There would be 4 cells, and you should go ahead and run those cells for yourself. I'll be also doing at my end. So don't go on the variables part. I'll cover few slides and then we'll again come back to variables. So from now on, it would be like theory and then practice, theory and then practice. So again, to print the addition, there are 2 ways. Either you can do direct 3 plus 5. Shift enter, it will give you results. Or in the same cell, if you put print 3 plus 5, and run it, you'll get the same result. So you can choose any of this and run those operations. So 385. So has everyone done this? Can you again give me thumbs up so that I understand, or if anyone still faces issue? Okay, so in case if I want to delete this cell, what would I do? Do you remember the shortcut? Yep, DD, and it gets deleted. No, so not on, yeah, press D twice, correct. So in now, if I want to add a new cell, I'll do just type A. And if I want to perform the same function, I'll just write it so that I don't miss it. 248. So what I mean to say is Python, the Jupyter Notebook performs operation as similar to a calculator. Now, with this exercise, we have a little bit of control or understanding as to how different cells execute a code. Just before going ahead with the variables theory, I wanted to add a new code. And if I want to type like a description of what I have done above, what I would do is I'll go onto this code drop down, click Markdown, and if I like type we we performed mathematical calculations dot, and if you print, just execute this code in the same way, hitting Shift Enter, you have a description. So now if you want to, like you see, I have descriptions as bolds, I have description as italics. So there is a norm which you can follow. So if you have selected Markdown, and if you click on the keyboard next to the Markdown, it will give you this tab where it will tell you what to do to create headings in the Markdown. I'll show you through an example. I'll just exit this as of now. So in the same line, if I write a hash, give it a space, it becomes bold and the font size increases. And if I hit Shift Enter, you can see what happened. So basically, these commands could be used to create titles, subtitles, subheader, header, whatever you would like to call in your script. So this is just for example. If you want to do, you can do this at your end, but it helps in again describing and helping with the code. I'll leave it like that only if you want to refer it later. So let me come back to the presentations before we start the variables section. I have again a few slides for that so that we understand what is variables, and then we'll start with the coding aspect. Okay. So in Python, there are several data types. The most common ones are numbers, which you'll be playing with a lot. strings or characters, booleans. There is another variable type also, which is called as grouped variables or sometimes matrices, mainly grouped variables. But the major three ones are numbers, strings, and booleans. Numbers mainly consist of simple and complex numbers. So I'll explain that later. Just go ahead with this. Grouped variables consist of lists, sets, tuples, and dictionaries. If you are describing a number within a parenthesis, whether it's a round bracket, whether it's a square bracket or a curly bracket, according to it, the definition of the group variable changes. If you are playing with words or letters, those things are called strings or characters in Python. And if you are trying to run a conditional statement or trying to take a decision, trying to do a decision making thing, you use a data type or a variable called as booleans. Boolean mainly means true or false, on or off, 1 or 0. We will be covering these with examples. Right now, just be aware that these are the four main data types. So what is variables? Let's understand that. So variables will be placeholders for all the data that we'll be working with. It will hold numbers, names, values, and a lot of other things you basically assign to them. It is important to note that variables are volatile. So I'll show you with an example. And if you could answer me, because I'm not seeing Teams, what would happen? It would be great. So by volatile, what I mean is.
Nikhil, we have a question in the chat box, if you can answer it.
Let me access it. Is everything we just outputted from performing the operations number type or string type? So if I understand your questions, so do you mean the calculator function which we did just right now? What is the kind of variable we used? Is that what your question is? And if it is, we used integers or numbered variables, number type. I will be covering what is numbers in coming slides, so you will, I think, get an understanding. I'll be going through it. Okay, so by volatile, I mean to say that once you end the script, the variables are ejected and deleted from memory. So for example, or for instance, let's understand this example and you'll get clear idea of what will happen. So if initially I define a variable x as a number 1 and y as a number 2 and try to find and specify or create a condition called as x equals to y, what would be the output you would be expecting if you're running this code? So initiated the variable with defining a value x equals to 1, y equals to 2. So will this condition print 1 or will this condition print 2?
Would it be neither because like the form doesn't work since they're already set as something different?
Why it would be neither? Because
I guess I'm confused just because x equals 1 and y equals 2. So to set one equal to the other, wouldn't it like not
got it,
work?
got it. So yes, you are right when you say that nothing will get printed, but the reason is nothing will get printed because we did not print anything. Okay, that's the main reason, because the code is not complete. The one which you're saying, what happens, the convention within Python is that the variable assignment happens in a single direction or in one direction. So for instance, if when you said x equals to y, if earlier the value of x was 1 and y was 2, when according to the Python convention, the value of 2 will be assigned to x. So x will become 2. So in Python, left will always replace the right. We will try this on the script and you will yourself get how this convention works. So that is how the volatility works. And the main point to note here from this slide is the variable assignment always happens in one direction. We'll be going through the exercise and you yourself will find out how it's happening. We looked at some basic operators, which we already tested. Now the main use of these operators are to manipulate the data that we have. So like division, multiplication. But there are some other operators also. For example, integer division, where you essentially round off or cut off the decimal portion. Or you have something called as exponential. So there's a way to there's a method to write exponential operators while performing exponential mathematical calculations. So rest of them are like as similar as to what you have been doing on a TI calculator, and it applies basic mathematical rules. So operations in Python happens in a similar way as to what happens in your calculator. Just there's a difference in some operations. So numbers, as somebody asked. So let me say like that. So numbers are mainly of three types. Yeah, they are either integers within Python. So all these are within Python. Don't take it as like normal numbers definition, how Python sees numbers. So there are three types of numbers within Pythons. It could be either integers, floating point, or complex numbers. Any real number, that is a number which has both integer part and the fractional part. Or in an easy way to understand, if a number that has a fraction that it has a decimal, that type of number in Python is called as a floating point or a float. Integers are numbers which are without decimals. So for example, in the exercise which you see on the right hand side, if x equals to 1, that is an integer because it does not have a decimal point. Once it has a decimal point, it is called as a float or a floating point. Then there are other types of numbers which are also called as complex numbers. They are used very less often, but to give you a sense, they could be called as real numbers or imaginary numbers. So depending on your use case, you may use either an integer or a floating point number. Then the other variables are strings or characters. So characters are computers' way of interpreting numbers as symbols or letters found on keyboard. So for example, character A, if it's within a quote, single quote, it's a character. If you write hello everyone and keep it in a double quotes, it is a string. So any string or a character within Python is denoted with quotes. So if it's a character notation, it would be in single notes. For example, A in quotes, percentage in quotes, or 5 in quotes. So 5 is a number, but if you put it in quotes, it will become a character. So Python understands that, OK, it's a character, it's not a number. So keep a note of it. And there are several operations where it depends again on the use case where you change the type of a particular variable which you define. So in such situations, it becomes very much necessary to be aware about what kind of variables we are playing with. So the main difference, as I said, if it's in a double quote, it's a string. It will be always if any string you are working with, you should always put it inside a double quote. Essentially, in a Jupyter notebook, when you work either with characters or strings, what I have seen is if you put a single quote or a double quote, it more or less does the same job. But a notable difference which I want to bring or highlight right now is that string should be in double quotes and character should be in single quotes. One important point also is that strings are immutable. That means that once they are created, they cannot be altered directly. So as I said, you will have to change the types. So for example, you specify a number 5 as a string. So how do you do that? 5 is an integer. Maybe it was earlier defined as an integer number, and now you are converting into a string. So you will have to use certain Python default functions, pre-built functions that help you to change its status from a number to a string. So I think this is about a little bit information on what is variable. And I think we can again go back to the hands-on exercise. If I see the time, and it's not break. OK, we can do that, some portion of it in 5 minutes. So if you can go back again to your Jupyter notebook, there's a new exercise called as variables in Python. And after each of these headers, I have written refer slide for explanation. So whenever you are coming back to this Python notebook for your understanding later, these sections could help you get back to the PPT and check, OK, this is what I have to refer for understanding or where I could have gone wrong. So in this exercise, in the first exercise, we are creating a variable called as savings. So we are assigning savings with a number, which is integer right now, 1500. So we are basically defining savings. And then after we define savings, we try to print what is our saving, or what would be the output of our definition. So I'll do that quickly along with you, and I will also request you all to do within your Jupyter notebooks. So to do that, just create a variable which right now is called savings and save it with 1500. So basically you have assigned 1500 number or an integer to a variable named as savings. So if you hit shift, no, not right now. And if you now print savings, and if you now hit shift enter or run the code, it will give you a value of 1500. That means the variable named saving has a value of 1500 stored with it. Now, if you could, now for example, although I don't want to change this, but I'll show you. If I would say that my another variable expense is equals to 3000, and if I say print expense. So another variable I created, it's called as expense, assigned it 3000 and try to find out, OK, whether this value has been assigned to that variable or not. So now if I do a mathematical operation, since it's a number, let me try to do that and see, sorry, not a. Okay. So if I say, let's keep a variable, very random variable, maybe name, and I have my expense and I have savings. I'm just trying to calculate what's the difference and see whether it works or not. So let's see if it works or not. So it says here, OK, savings. So if it's better, like it's nice that we got an error. So it automatically shows that we did not put the right variable name here. That's why it's gave an error saying that, the name saving is not defined. You did not define anything called saving. So that's why it is giving that error. So now let's try to run the code again and check if it prints something or not. So the reason it didn't print any value is because the command ran, but it didn't print anything because we did not ask it to print. So if we put again a print command and write the variable name and run again, it gave me it did a certain operation and gave me the value now stored in that particular nick variable. So this is how I'm just trying to explain through examples that you can assign several variables, any type of variables to with a particular name and perform certain operations using it. But note that these operations won't work as it's happening right now. So right now, since the variables are stored as numbers, the calculation happens. But once the variable changes to list, maybe the operation won't work exactly what you're seeing right now. So we will be seeing again that later. But if you have understood this exercise, I would like you to perform this exercise on your own Jupyter notebooks, where we create a variable called as daily savings and number of days. Then we try to find out what are these savings. So we are trying to calculate a new saving by multiplying the daily saving with number of days. So we created a new variable called as new savings. Now we want to find out what are our total savings. So what we did is we performed a numerical, basically addition to our new variable, new savings, plus our older variable, which we defined earlier called savings. So after the addition, I'm trying to print what is the result stored in the total savings variable. So I would like you all to do this exercise, and I'll be waiting for you all to do it in your Jupyter notebooks.
Nikhil, someone is having
Yeah, I saw
problem.
that. Right.
Yeah, so you can just show them how to add a cell.
Yep. So what you could do is there are two ways. One, you could, for example, this is the cell. First, click on the cell and hit this plus button that is already told. Or if you hit this cell and click B on your keyboard, it will create a new cell below your cell. And if you select a cell again, and if you want to create a cell above rather than below, you click on A, so it will create a new cell above. So that's how you create cells below or above. So everyone, I hope, is doing this exercise. I would be also completing this with you. Another thing which I forgot right now is, for example, you want to write a comment. So to write a comment within a cell, you can use a hashtag. And for example, here I am defining. If you could see I can zoom in maybe. Defining daily savings and days, number of days. So this is also another way of describing your code. If you put a hashtag and write something in front of that, you can basically describe that part of the code. But other than that, instead of just defining or describing the code, when you are playing with several models, if whenever in future you play with several models and you are sharing those files within your peers, you can use this hashtag to inform them what's happening in the code below if they are not aware. So this is another common thing which you would be seeing in Jupyter Notebook. So whenever you see a hashtag within a code cell, just think that it's a comment and it won't execute. So it won't give you anything. It will be just like what's printing out. That's all.
Nikhil, I think we have a 15 minutes break home.
Yep. So Junaid, let's finish this exercise. It's like just total savings, and I'll finish them with them so that they can also, do it there, and I'll take a break. So your number should come with somewhere near 6975. If you're getting that, means you have written your code correctly. I think Junaid, we can then take break here, right?
Yeah, it's up to you. I mean, it's up to you.
Okay, so I am staying here. Those who want to take a break, you can go. And we'll have a 15 minutes break. And if anyone has any question, I'm here, you can ask. I'm just on mute.
Are you still there?
Let me clear the doubt. So if you have savings already defined and you ran that before, and after that, if you have followed this program and run each and every cell, I think it should print total savings. So what it's basically doing is, in this new section of the code, you define two different variables, assigning it to a new variable called as new savings. And when you're calculating your new savings, basically if you're calculating your total savings, you basically add your new savings and your savings which you had earlier before. So if this cell you did not run, it will always give you an error. So what I mean to say is, if you're keeping your all these codes in a single cell and run that cell, then it will work perfectly. But if you're keeping all these codes in a different cell, you need to run them sequentially one by one. I hope that should answer your question. Okay, so
Thank you. I'll try it again.
yep. Or if it's not running and if you want for the sake of the exercise, you can copy paste and it should work also right now. So just that if it has any dependencies later, it won't give you an error. Okay, so we'll continue with this exercise where now till now we assigned numbers. Now we are assigning floats, strings, and booleans. So we are assigning three different variables. So if you could assign also with me in your Jupyter Labs. So the exercise is basically assigning three different variables. Till now, we only were playing with numbers, that too specifically integers. In the next exercise, we are creating three different variables with three different data types or variables. So put half equals 2.5. And if you in the same line, if you could print half, it will give you value of 0.5. So there is an alternate way which Jupyter offers where you don't need to write print in front of half. So the convention of printing the name which we were following till now, where we used to do like this, print half within round brackets. This is also a way of printing the value. The another way is just if you write half and hit shift enter, it will give you 0.5. Both are similar, so you can follow anything. I like to follow print because I've been doing it since a long time like that. But Jupyter offers this flexibility where you can directly print the name of the variable. So for example, now I have to create a new variable called as intro. And I name it as hello. How are you? And if I hit shift enter, sorry, I didn't printed that. So print intro. After shift enter, so how it's working, just to explain the working, when you create a variable, define it, the definition happens. So when you define it and when you run that part of the cell, it goes into kernel of the Python, looks, okay, this is the variable name intro. It's defined by a string called as hello, how are you? And then it goes to the next step. Okay, now it has asked me to print intro. So again goes back to kernel, again looks at the command that has been asked, and it prints the required variable. Lastly, if you copy the Boolean part and run it, print is good. It will print true. Now we just did a simple exercise of defining other variables. Now we are going to try something new. In the exercise before, we performed an addition between two variables that were defined as integers. Now, in this exercise, we are calculating the sum of intro So the intro variable we just defined, we are trying to sum that. So and see what gets printed. So we sum two intro variables and name it as a different variable called as double intro, and then print double intro. So try doing that and see how the addition of a string works. So I'll also do. So intro we already defined above. If somebody has missed that part, you need to define intro, hit Shift Enter, click outside a cell, click on B to create a cell below. Create a new variable where we are trying to print intro. We are trying to perform summation of two intros. So double, I named it as double intro equals to intro plus intro, hit Shift Enter, or you can in the same code, click Enter and print double intro. Hit Shift Enter. So you see the output, it didn't add or it didn't do any kind of mathematical calculation. It basically printed the string 2 times next to each other. So hello, how are you? Question mark. No space in between, nothing, just in continuation because we asked it to sum. Hello, how are you? Now this doesn't look correct when we are playing with our original data later. So to create or print this correctly, to at least make some sense if we are working with a sentence or a data where we are trying to print a sentence, we need to add maybe a space would work. So I created another example of how do you add space between two strings. So now I'm changing the definition of double intro. So I'll tell you how we can do. First, I'll do this and show you how it works out. So if you see closely observe, there is a space between question mark and H here. Now, my question is, if we wanted to do the same thing, but in a different way, what do you think? How could we do it? So can I create a new variable called as space and save an empty string which has only one space in between? And then if I create this double intro, define this double intro again, which is summation of intro plus space plus intro. And if I print double intro, check, we get the same result. So what I mean to say essentially is there are several ways of doing the same code. You can define the flexibility is if you have a lot of different uh, functions or operations that you have to carry out, you can basically create it or define it as a separate variable and make it easier for yourself to put it in the code. So before finishing the last step, I would like you all to finish up till this part. So I want you all to print the double intro with the space, and once you are done, we'll complete the last part of this exercise. So I'll wait for a minute, and after a minute, if I could get again few thumbs ups so that I understand that you guys are with me. If I am very fast, you could let me know. I can get more slow, and don't hesitate to ask questions. I understand that you may. It depends on the system, internet speed. Sometimes it loads slowly. So we can wait, not a big deal. Okay, I'll go a little bit slower. So were you able to solve your issue of printing total savings, or you were still stuck?
I haven't been able to go back just yet. I started, but I'll get it eventually. I'll come back to you on that one.
Okay, okay.
Thank
So I
you.
think, Junaid, we have office hours too, right? In the evening. So
Uh,
I'm
even
sorry.
Yes, actually, yeah, that's a good point. Also, we can let the students know that we have office hours daily, actually, so they can contact us like even anytime what is appropriate for them beyond like specific
yeah,
office
so
hours.
what Junaid essentially means to say is that after each day, we are scheduled to have an office hours. That means we are available with you for you guys if you are facing any issues. And at the same time, as what Junaid said just right now, that we would be responding quickly also. So if you just post an email or a message, we'll respond it as quickly as possible. It's not a problem on that part. Okay, so just to finish this exercise, lastly, what we are trying to do is we are amalgamating what we saved earlier. So if you remember the savings calculation, we are trying to just print a sentence where we are adding different strings. And right now, what we are basically trying to do is we are changing the nature of the variables. For example, savings was a what was savings? Do you remember what was the variable type of savings? Do you remember? If anybody can write what was the type of the savings? Oh, right. Yes, it was a number. It was an integer. You're right. So those who correct guessed incorrectly, the simpler way to find out is, so for example, I'll go back to that savings one where we define savings. I'll create a new cell here below. And if you want to find out, right, like you don't know, you don't have any idea or you forgot, what you can do is you can use a function called as type function. If you can use print type, and if you can open parenthesis and put your variable called as savings inside it and run it, it will give you the class in which it is defined. So Python understands right now it as an integer. A quick question. If I had my savings defined as 1500.50, what do you expect? What would be the type it would print out? Can you guess what kind of type it would print out? So instead of 1500, if I had 1500.50,
A double.
a float, a float. So a float or a floating point number. So you remember any number with a decimal point, Python understands it as a float. Without a decimal point, it understands it as a integer. Okay, so in this exercise, in the last exercise, what I'm trying to do is I am trying to do a summation between strings and integers. My main idea is I want to print a sentence where I print like this. I start with $1500 and now I have $6,000 something. That's awesome. Something like that. But the difficulty is, for example, I'll write that. I'll write this and show you what happens. So this is how we do it, and I'll tell you how the error, if we don't go through this process, what error it will print out. So right now it printed perfectly. So I basically did a very simple summation between a string. We created, basically changed the type of the integer to a string by using a string function. Again, adding it with a string, then again changing the type, and then again adding a string. If there was a scenario where I did not convert it to a string, the integers, so I remove the string function. And if I try to run this command again, it will throw me an error. And it says in the type, can only concatenate string, not integers to string. So it specifically tells you, it informs you that you cannot basically sum strings and integers. You need to convert them into a same type. So I would request everyone to run this command in your systems. And if you want, you can create a shorter one also. So again, once you are done with this, I'm leaving the error code right in the Jupyter notebook so that when you come back and refer, you understand what error you don't have to do. So again, when you are done, give me a few more thumbs ups and we will continue with the exercises ahead. And if you have any questions, don't feel free to ask them. So yes, Christina, savings was a number, but in number it's specifically integers. Okay. I am getting syntax error. Can you share a snip or something like that so that we get an idea? So I will run the maybe this code in another fashion so that it becomes easy again. So what I'll do is I'll assign variables. So I define like a equals to a string. I started with dollars, control C, control V, and then I will say b equals to string name. I keep C equals to awesome. Then I keep space 1 equals to then space 2 equals to. Okay, great. And if I create a variable, or let's leave it like that. And if I try print a plus convert my integer to string plus. Now I want a space, so I'll put plus space 1 plus b plus. Now I have a space 2 plus C. Let me check what's the output, and if there are errors, we will change them. So it says it's the error. Why should I related to like this? So it essentially prints the same thing. I started with 1500 and now have dollars saving. Again, this you don't need to do that. I'm just showing a different way of solving the same problem, and basically manipulating your data set. So now before moving forward to lists, let me explain what is list. Okay. So this is one of the most common variables that you would be using, because whenever you start with a data set, whether it's in a form of a table, whether it's an Excel file, whether it's a CSV file, or you break your data into these kind of formats, at the end of the day, Python you will be converting them into lists, and those lists will be converted into data frames that will be used by Python to understand what the data is, what's the nature of the data, what is the format of the data, and then it will then if you depending upon the tasks that you assign, it will perform data manipulations and visualizations. So grouped variable data has 4 different types. It has tuples, it has list, set, and dictionary. I have a very beautiful example to understand what's the main difference between these 4 different types of tuples. But slide will definitely these slides will help you also to understand and make yourself informed about the differences between these different grouped data variables. So a tuple would be always represented by a round bracket in your data set. And I'll show you first what are the main difference. So a tuple would be always defined in a round bracket, a list in a square bracket, a set in a curly bracket or with set and round bracket, a dictionary with curly bracket. Now, what is basically these types? So these are nothing but representations of showing your data. So in tuples you can show your data, like for example, t equals to 2, 2, 4. You show this data, but whenever you perform mathematical operations or you want to do any kind of calculations with your data, which is arranged in a tuple format, you cannot play with single elements. If you perform for example, I want to multiply this tuple by 2, all of the elements within this tuple would be multiplied by 2. So this is where lists benefits us. So in lists, if I wanted to do the same function, and if I just change the parenthesis, the brackets to square brackets, and if I want to say I only wanted to multiply 2 or 4 with 2, I can write that kind of code. So this is where list comes to benefit to us. Again, the difference, round brackets, square brackets. Now, when it comes to set, so for example, again, the same data set t equals to 2, 2, 4. If you put it in curly brackets or write it with set with a round bracket, what it would do essentially is, since 2 is repeating 2 times, it will remove 1, 2 and remove all the repeating elements. Only unique elements would be present within a set definition of your data. So again, it depends a lot of what kind of use case you are deploying or use case you are trying to perform an analysis. So it depends a lot on that, and on that basis you select whether you will be defining your data as a tuple, list, or a set. Lastly, dictionaries. Dictionaries are very great, and they come quite handy when you want to tag your data set. So basically, if you see this data also, you can correlate it with MS Excel. So if you have your first column, you can tag it as column 1, and within column 1, you can have list values as 1, 2, then column 2, 3, 4. Similarly, so basically dictionary tags your list. Now let me explain this with an example. So for instance, I have a tuple of all the students within the class, and I want to assign a grade to all the students. So I have a list of students. So how do and I want to assign the same kind of grade. So maybe I want to give A grade to everyone. So in that case, I will define my students data set in a form of a tuple because I want to perform a similar function where I'm grading or giving equal marks to everybody. That is where tuple will be handy for me. Now, in case if I want to assign a separate grade, so selective student, selective grade, few students, few other grades. So I want to pinpoint grades. So maybe I'm doing a final grading at the end of the semester, and for each student, I have to grade differently. So I can then create the data set in a form of a list. So that list will help me perform actions regarding grading individually. Now, the only added condition with sets is that each element has to be unique, which I said earlier. So if I'm grading, I can't account for the same student twice. So you can understand that I only have a unique grade and a unique student, which will I have to assign a unique grade. So anyways, whenever I have a list of students, that would be unique in itself. So I can use a set in that case too. But there may be conditions. I'm trying to explain with a student grading example, but there may be conditions where this kind of format won't exist. Finally, if I want to create a list for myself where I'm trying to look how many students and their names who have got A grade or B grade or C grade. So I can create a list of those students with A grade separated by commas and separated by commas like this, like for example, name John or Max, something like that. And then I would say that the grade A is the tag of these students. So if I have the flexibility to, Python offers this flexibility to assign a tag to your data set. So whenever you're working with this kind of data, you essentially would be using dictionaries. Now we'll go back again to the exercise, but before going to exercise, if anybody has any questions, they can ask me in the chats if they did not understand. Okay, so we'll create a list and the exercise is we'll define a list of areas of zones or spaces within a particular building. We'll create this list and name that list as areas and print the areas and check what comes out. So let's do this. And then we'll have some functions we'll be playing with lists, manipulating lists, and we'll automatically understand how this works. So right now in these exercises, I have included lists and dictionaries because those are one of the most common ones which you would be also playing with. So yeah, let's go ahead and try those first. So in the first part, we are defining a list, and to do that, we first define our area variables. So what are those variables? Hall. What is the area? 250. And right now it's in form of a float. So in the same way, you can also add the data set or simply copy paste also. So once you have the variables defined for your list, you can run this cell, go into the next cell, and now create a list called as areas. So to create that list, simply create a name of a list called as areas. List comes in a square bracket, so click create a square bracket. and write the names of the variables that you want to plot in the list. So for example, hall separated by commas, hall space kitchen space living room by live space bedroom space bathroom. So once you do that, once you have I'll be again explaining that, so don't mind if I'm getting very fast, going very fast, but I'll be explaining again if anyone gets into trouble with this. But we are performing very basic functions right now. Assign created variables, and then I am trying to assign that all those variables to a list called as areas. And the next step, you can just simply print those areas. If you hit Shift Enter, since we did not run the above cell, it gave me an error. So what it basically does, this code is helping you create a list of variables which you define by your own, called as areas, and print the list and see what the list prints. So just like how I talked about examples of students, where you can provide names of different students, name it as a list, and then you can print their grades or their age or degree, whatever you want to. So once you are done, again, give me a thumbs up. But before going to that, going ahead with that, there is a way where you can also look or check what is the data type or what is the variable type. So again, use the type function. For example, print open parenthesis type, and again areas. And if you hit Shift Enter, it will show you this. This is a list. The variable just you defined is called as a list. It's within the class list. So I'm showing you an alternate way that if you don't know what kind of data you are looking at, for example, you are accessing a data from the web. Dr. Chakravarti and Dr. Jessica were discussing a lot of open data sets yesterday. A lot of talk about that. So for example, you are getting some data set from an online portal, and you don't know what is the type of that data set. And for example, you have a data set maybe of an area of a building, and you want to just show you want to plot a histogram and try to find out the distribution of the areas of the buildings. And if the data set is coming in a string format, it would give you a trouble or an error to analyze that. So before going ahead and working with the data set, it is better to check what's the type of that particular data set. So if you are done with this, the next exercise is creating a list within lists. So it's the technical or the conventional format to call it is list of lists. So again, right now I defined areas of spaces within my home or house. Now what I'm trying to call is I want to specifically create a list or inform someone who is looking at my code that hall means hallway, and the area associated with hall is, for example, 250, should get printed and come out when you observe a list. So the convention remains simple. Since list is inside square brackets, you create a variable called as house. You open a big list, and within that list, now you have to create lists. So for example, hallway is a string which you want to print out. You want to print this name, hallway. And with hallway, you want to print the area of that hallway. So since we already defined the variable hall, when we call it, it will print the area of that particular hall next to hallway, separated by commas. In the same fashion, now keep doing this with me, write this code with me so that you don't get into confusion. Kitchen, comma, kit, and rest of the codes. And don't forget to close the square bracket, otherwise again it will throw an error. So you created a bigger list, and within that bigger list, you created small lists, separating it by commas. So now just imagine if you are working with columns of Excel files for analyzing data, how to get it into the Python. This could be a simpler way or a straightforward way. So if you run this, it says and invalid syntax. So somewhere we missed defining. OK, so it says that the bracket is not closed properly. So close this. OK. And maybe like this, and then it's another. Oh yeah, sorry. Thank you. Yep. Print house. So yeah, this is how the print command works. So now you have the name of that particular space. In front of that, you have its respective area. A list within a list. Similarly, as we are looking at the type functions before, you can look at the type of the list which we just defined, copy paste the type. You already know, use a print function, put a type function between the parentheses, and add the variable that you want to look for, and just hit, and it will again tell that it's a list. So any doubts up till here? I'll wait for again few minutes for the people who are doing. And I am monitoring chat, so if you have any question or if you want to speak with any doubts, you can come up. OK, so I am assuming that everyone did till here with me. And now, before going ahead with next exercise of Python indexing, let me tell you what is Python indexing. In very simple words, Python indexing allows you to access specific items within your lists. To do that, it calls their position, and you can use that position number with the variables to print out that particular element within the list. So to understand that, if I have this word justice space 1, and if I want to call the word J, or let's understand how the indexing works. What does indexing mean? So as I said, indexing generates a position or a sequence of position for the variable type that you are using. So in case of justice, if I want to call J, it will have an index or a position of 0. So always index starts with 0 and it goes ahead depending upon the type of data set that you have. So for example, now if I want to, if this is basically an array of string. or it's just a characters, and I want to call a character t. So I will be using a function which calls this t, which looks for this t by looking at its position. So to find its position, it will go in the program, look at its position 0. OK, not t. Sorry, 1, 2, 3. So I'll type 3 within the code and it should give me this position t. So this is how we can deploy index command to call out specific elements within the variable type. The convention works in two ways. Either it starts from 0, which will call the first item, or it will start from -1 being the last item. So if you want to call the last item, if you give the index as -1, it will print out the value or the element in the last part from the end. So basically, indexing makes it quite easy to retrieve or modify particular elements within the lists. So for example, I mistakenly saved a name of a student. I incorrectly saved the name of a student and I want to change the name of a student. So it does not make sense for me to change or look at the names of all the students. It would make much better sense if I just go and call to the position of the name of a student, call the name and change it with the correct spelling or the correct name. So if we want to make individual manipulations or modifications, it becomes quite easier. And I think this indexing is unique to Python. I'm not aware about the same indexing pattern if it happens with other programming languages also, but it's a common convention used in Python. The other main aspect that you will come across list is slicing. So slicing simply means extracting specific sections of a list. OK, I think I have an exercise and then I'll go with the explanation of slicing. So again, let's go back to the exercise and perform the indexing portion first. Just a second. OK. So as I said, so in this exercise, we already have an areas list, which we just defined before, or you can call it as a house. I think I mistakenly saved it. So instead of areas, you can keep it as house. So I'll just copy this. Don't keep it as areas, or maybe let's go with areas only because there are functions correlated with the definition in the later parts. Anyways, leave it like that. So in this particular exercise, what we're trying to do is we have a list of areas with respective space names. We go ahead and call out separate sections of those lists, separate elements of those lists using the index commands. So for example, I want to print second element from areas list. So if you don't follow the indexing convention, the second element is 250. Now I want to use indexing function to call this 250. So how do I do that? I look at its index position. So using index, 0 means hallway. 0 is the position of hallway. 1 is 250. So if I print areas in square brackets 1, I'll get the value 250. In case I want to print kitchen, my index would be 0, 1, and 2. So 2. Similarly, it goes ahead. So for example, now I think I want to take out this value 20.35. So in that case, I'll use an index of -1. So go ahead and try doing this. And then I have slight variations no, I think I have that in slicing. So go ahead and try doing this and check for yourself. And once you're done, I'll ask then few other random positions and you can answer me that in chats. So initially create an area, define an area of define a list called as areas, run that, use print commands to print the second element. You can put it in a single cell also. The last element. And the fifth element. If you hit enter, it will give you values 250 because its index is 1. Value 20.35 because we called it as -1. And value of 5 means 0, 1, 2, 3, 4, 5, so 175.75. So this is how you call elements within a list using indexing. Now, if I ask you that I want to print bathroom, so what indexing number should I put? Can you answer that? And there are two answers for this. So what would be the, it would be great if I get both of the answers. -2 is right. So if you can do it yourself, so print. Okay, let's try that, both of them. Somebody said 9. So print areas, square brackets, -2. I got bathroom. And same convention. Print areas, square brackets. How much? 8 or 9? No, 9 doesn't work. I think it's 8. Yep. So yeah, so this is how you can call elements from the list on your own. Now let's again, let me get back to slides to understand how do you slice lists. Okay, so as I said, slicing is used for extracting specific sections of the list. You can also extract individual elements, but more or less if you want to extract larger sections, if you have long list, and if you want to extract a large section in that list, you can include slicing commands. So slicing, again, since we are playing with lists, it has a convention of using square brackets. But for example, if what it does is if we want to include certain portion, for example, we want to, or let me directly go through the example and explain, but just remember that the convention includes the starting, whichever starting index number we define, it will include that. And whatever ending index number we'll provide, it will exclude that portion of the list. So if we have index position 1 to 5, it will have the element stored at first position till 4th position. It will not include the 5th position. So keep that in mind. It will include the first element, the first index, but not include the second index within a list. So again, let's again understand that with an exercise. So I have the same list called as areas. We'll be working on the same list. And in this exercise, what we are trying to do is we are trying to create two different lists called as downstairs and upstairs. What downstairs means is we'll have hallway, kitchen, and living room. That means 6 elements of the areas will be included in downstairs list, and the remaining 4 elements would come in upstairs. So basically, we are trying to manipulate our data now. So as I told you, and I'll try to explain this again after running it. So downstairs is a name of the new list. areas was the list which we were working on. And as we want first 6 elements of the areas within the downstairs list, we give a slicing command of 0:6. So when we say that, we expect that if we are giving an index position of 0, it will include hallway. And it will exclude the 6th index position. So 0, 1, 2, 3, 4, 5, 6. So the convention is it will exclude the 6th position element. So I'll print and show you the results and you'll understand how the slicing works. So print downstairs. So you see 0, it included the first element, 1, 2, 3, 4, 5. So 0, 1, 2, 3, 4, 5, 6. So included the 6, it included 6 elements, but when it comes to index position, it did not include the 6th position element. So this is how slicing works. So in the same way, upstairs, I print the last 4 elements. So in this case, what will happen? 0, 1, 2, 3, 4, 5, 6. So I start with 6. So 6th, this is the 6th index position. So this will get printed. 7th will get printed. Sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So 6th will get printed, 7th will get printed, 8th will get printed, and 9th will get printed. Since there is no 10th position, or even if I include a 10th position called as XYZ, just in case you don't confuse. Run this commands again. So it will print the 6th, 7th, 8th, and 9th. It will not print the 10th position. It will exclude it. So if you remember the slicing command, include the first position. Don't include the position in the second part or exclude it. If you now print it, it will give me, how did it give me hallway? No, it should include. Okay. Okay, I think I'll have to define areas again. Seems. Yeah. I think it should work. Okay, I did a mistake. So instead of downstairs, I need to print upstairs, right? You know what was the error? I was printing downstairs, but I was defining upstairs. So that was the error. So just look at the syntax correctly. So basically what it did is it went, looked for the 6th position element, looked at the 10th position element, removed the 10th position element, and only printed from 6th to 9th positions. We'll play a little bit, make some edits. Yep, so there was no position at 10th element, so it will automatically not include anything. And I just defined it for the sake of simplification, but if there is nothing, it will just ignore it and it will only print till 9th. So even if you put 12 and if you don't have, then it may give error, but if you have only limited lists, it will give you whatever positions you define. There is an alternate way which I would like to show you. I'll little bit increase my speed so that we keep the momentum of time too. So in case I want to, this is a new method of slicing. So I'll just type as new method of slicing. So for example, I wanted to print the same thing like downstairs. What I could do is I could call the areas list, open the parenthesis or square brackets. The other convention could be questions in the chat. Okay, so the other convention could be you write a colon, and since we don't want the last 4 elements, and I'll keep a just for the sake. Okay, I'll keep a list. Just observe this, what's happening. It will basically give the same result, but the way of writing is different. So if you want everything included, you'll leave blank in the first position. And if you write -4, what it would basically do is remove all the last 4 elements. So now if you print, it will essentially give the same results. This is another convention or a shortcut, I would say, but you don't need to do it. I'm just trying to show to you that the same results could be done in this way also. You don't need to do this. I'm just showing you how you can get the same results using slicing. So there are different ways of slicing. The most basic way is this one, and there are then shortcuts of conventions also. So if anyone has not, if anyone is able to, everyone is able to run these commands, just let me know, then I can, go ahead with the final exercise of the lists. Okay, I got 1 thumbs up. Or you have questions, then just put it in the chat. I think I have my chat open. I'll wait again for a minute. Sorry. Okay, so last exercise of the list is, in case till now what we did is we created a list, we manipulated the portions of the list, sliced the list, called a particular element of a list. The last exercise is if we want to extend our list, so add new elements within the list. So how do we do that? Again, I will call my list that I created above areas. Run that. So this is my list. In this list, I want to add 2 more elements called as pool house and 240.50. That is its area. So to do that, I simply create a new variable called as new areas, and I sum it. So I have areas defined before. I sum it by creating a new list called as pool house with its area. Sorry, 40.50. And if I run this and print new areas, new underscore areas, I get the extended elements within my older list. So this is a basic operations you can perform on list to add elements, delete elements, I hope everybody is with me till now. Now, I also explained dictionary. It was another data type, sorry, variable type. But the difference between a list and dictionary was that list was in a square bracket, dictionary remains in a curly bracket, defines in a curly bracket. It gets separated by colons and commas. In list, you have only commas. And the main difference is in a dictionary, you can tag your list. So this also I've explained through an example where I create a dictionary of the first for 2 list. Sorry, I create a dictionary for first and the last names. So just follow with me to understand how to create a dictionary. So I call a dictionary called as a dictionary. Convention is open a curly bracket. create a tag. Let me write as first name within first, separate it with a colon, create a new list. So the tag for that list is first, and I type my name. I type another name. Okay, I'm just putting two names. And then I want to create another tag within dictionary. Sorry, I have to do that before the curly bracket closes. So comma, separate it, create a new tag of last name, put a space, put a colon, create a new list. And I forgot to define it as a string. It will give me an error if I don't do that, because Python does not know what type of data it is. So I put my name as string, create a comma, understand. And now if I define this and print the first tag, it will give me the definitions of the list under that tag. This is how a dictionary works. It's very similar to a list. Operations are also similar to a list. The only difference is how you define a dictionary. You create a tag for a dictionary. For example, I have 10 buildings, building 1, building 2, building 3, building 4. And for those 10 buildings, I have 10 different energy consumption values. So I can create a tag called as building 1, energy consumption values, building 2, or something like that. So I'm just trying to help you understand that how these functions, commands could be used for your own data set. Now, as what we learned in lists of calling index to understand what is the element, we can utilize the same command in dictionaries too. So here, what I did is I printed the tag. I tried to print a tag and understand what it contains. In the next exercise, what I did is I called the tag, and within tag, I wanted to know the so I give the index 0 and try to find out what is the element coming out of my dictionary. So I do that. I'll just run it. So you get the name Nikhil. If I change it to 1, it will put James. So whatever you define, again, same process. You are calling the element through the index position. So this is similar. The list, it's similar with list. And the slicing functions also work with dictionary, although I've not included in today's exercise. But if you follow similar commands with little bit changes in dictionary regarding slicing methods, it will work similarly. So for example, if I put like -1 here, it will give me again James. If I put like -2, it should give me Nikhil, something like this. I hope everyone was with me. I went a little bit fast in this because we are very near to our session. And let me go over it quickly and just introduce you to the remaining parts so that we don't miss the important parts too. I have still 10-15 slides, but I'll be going a little bit faster so that at least I cover everything which I have. So let me go about everything, get everything on the slide. So for example, if you want to import libraries, so there are so you looked at list, you looked at dictionaries, but just imagine if you have a large Excel file having hundreds of columns and hundreds of rows, you can't you can't go manually define dictionaries every time. For each column, you have to specify the header, then add the elements in the form of lists. It becomes quite manually intensive. So what Python did is it came out with packages, or also called libraries, where you automate the tasks basically by using those libraries. So the most important command that you use to call a library is called as import. We have one import command in our exercise too. So this has a basic syntax where you just call import and the name of the library. You don't need to you don't need to include these signs, just the name of the library. Now think libraries as extra tools that you have on your table. It will basically supplement uh, it will basically help you in tackling a different set of problems which you face. So as I said, I forgot this. So if you see, if the NumPy is a very famous library, and if you want to call that library, you type import and call the name of the library. If it's pandas, you write import and call the name of that library. Here, pandas as PD means you're defining pandas as PD. So in the code later, you can use PD instead of writing pandas each time. So one important point to note here is that these libraries also have their own conventions. So if you're not aware about them, if you're not aware about the syntax associated with these libraries, you may make mistakes and you may not get what you would be expecting from the data. So in today's lecture, I plan to cover two different libraries. One was NumPy and the other was Pandas. I have again exercises for those. So I'll quickly go. NumPy is one of the most fundamental package that is used in Python. Uh, it mainly performs mathematical operations, mathematical computations. NumPy uh, has a primary variable type called as arrays. What arrays do? They are, or what arrays are? They are powerful data structures. They allow for efficient data manipulation and storage. So basically, whatever data you are trying to work on, they can be stored in a form of array, and then you can perform operations on those arrays. So NumPy arrays are automatically before built in, they are equipped with numerous functions. They are primarily used for handling large data sets and can be imported into Python. So just like pandas as PD, NumPy can be called as NP. Uh, a lot of its use is with CSV files and Excel files. So you will be playing a lot with NumPy when you would be analyzing your data sets. The other most famous library is Pandas. It again deals with manipulating data. They take input as lists and dictionaries and combines them into a unique class that has a lot of built-in functions. Pandas have an ability to save the files natively within the code, and you can use since it provides that flexibility, you can use it to read the data, edit the data that it contains. Pandas have two data types, that is pandas series and pandas data frame. The main difference is data frame is a series with more than one column. So you can see on your screen that a series has a single column, whereas a data frame, just like your Excel sheet, can have multiple columns. Pandas has again a lot of built-in abilities for visualization, and it is used by almost every data scientist. So again, when you look at the differences, as I said, series are single dimension, whereas data frames are multi-dimension. So I have again an exercise so that you can again go back to the functions and packages exercise to finish this section of the code. So We have been using print and type functions till now, so those are nothing but called as functions, and these are built-in functions that are provided by Python. Just like that, there are other functions also. For example, we converted the savings number before to a string to print that sentence. So similarly, you can change the nature of the data types using the functions. So let me define a variable and then change its type and see how it gets printed. So I'll be directly copying this and explaining you. So in this first section of the code, I created a new variable called as variable1, which is nothing but a list, and a variable 2 called as true, which is a boolean. So if I run it, and now if I try to look at the type of that data. So the first is list, the second is boolean, as what I explained. And in the next stage, what I try to do is I try to change the nature of the second variable. So for that, I create a new variable called as output2 and convert into an integer. So I use an integer function, keep variable2 inside and run it. And now if you print it, you need to note this. Since true equals to 1 and false equals to 0, and since we converted boolean into integer just right now and tried to print it, it gave me a value 1. So note this point. So whenever you change the change specifically booleans, keep a note that how the output changes. So although now if you would look at the type of the output, it will give you an integer. So let me again also go ahead because we have less time. Now the other important functions used in Python are also called as methods. And these methods are associated with objects so that you can perform mathematical operations, which you just did with lists, calling indexing, doing slicing, performing count function. So in this exercise, I use this variable called as areas. And I try to use index method and count method to find out the number of times 50 appears using count method, and what is the position of the element 250 using index method. So to do that, I use a print command. And note this, whenever I put a dot and I use an index right now here, dot index is nothing but a method. This is the method command which we are using. And what I want to know is what is the index of value 250.0. And I enter it, it gives me a value of 0. So the index position is 0. Similarly, you can make alterations and look for different index positions. So someone who was not aware about the indexing concept and wanted to learn or find out the position, or if you have a large data set and you want to look at the position of a particular point, you can use this indexing method. Again, the other most common method used is count. Common method used is count. So how many number of times you are getting A? How many students are getting A? How many buildings consume less energy than 10,000 kilowatt hours? So something like that, something where you want to count a thing, you use a count command. So similarly, instead of dot index, what I will put dot counter. Counter is dot count. In Excel, it's called counter. So it essentially means the same. It looks for a particular value. So for example, now I keep it as 250. And since it's only occurring once, it will give me 1. Now if I change it to 50, since it's occurring 2 times, it is giving me 2. So this is the main job of functions. So we already have used a lot of functions, but I wanted to just expose you through another inbuilt commands also called as methods, which are also called as functions, where you can directly deploy them for certain different tasks. So you can always go on Google and type different methods which we can use for data manipulation, and it will give you a list of different methods that you can deploy. We recently learned about NumPy packages. So as I said, to import a NumPy package, you will use an import command, call the library name. You can do it like this. So you basically imported NumPy library. Now I don't want to write NumPy each and every time. So I'll call import NumPy as NP. What it basically does is it follows a convention created by NumPy libraries, where now I can, instead of you writing NumPy each time, I can use NP. So each library again has its convention, but it basically makes your job easier. Now in this exercise of NumPy, using NumPy package, what we try to do is we try to create an array and then transform that array into a matrix. This is the goal. This was the goal of this exercise. So to do that, again, I'm keeping same list. We have been using this list from a long time. And now my goal is to convert this list into an array. And if you remember, we defined an array. But I think it would be better, instead of showing you through slides, I directly print the array and tell you how the results come when you print a list into an array. So to do that, I'm creating a variable called as a and changing the what is called list areas to a array. So numpy.array. So numpy is the library you are using. Dot array is the method of that particular library. And if you use areas, that means the variable that you are trying to change to an array. This is how you have to write that code. Now, if you just print area, print it. This is how it distributes each of it. Right now, it's similar looking to a list, because I have not specified anything. If I have not specified to put it inside a column or to put it inside a row or to convert it into a form of a matrix. But this is where NumPy becomes handy. So now I just printed it as an array. Now if I convert it into a matrix, that would help you understand how to manipulate your own data. So to do that, what I'm basically doing is using another method called as reshape and converting it into 2, 3. So 2 means rows, 2 rows and 3 columns. And now if I print A, it printed 2 rows and 3 columns. So this is how, if you have again your data in Excel sheet or on a CSV file in form of a list, you can specifically create your own matrix and perform operations on those metrics. So it is a very important library for data manipulation. Considering the time, I would like to move ahead and just go through these packages. I would like you all to do at your own end. Otherwise, so we have already crossed the time limit. So I'll just quickly go through each of these sections, and you can then maybe later look back at the video and understand. And if you have any questions, do reach out. The other most commonly used libraries is pandas. Again, how do we call it? We call it as simply by importing. So import pandas. Now we don't want to use pandas. Sorry. So we call it as import pandas as PD. Now we called import pandas as PD. So we'll be using PD to call or perform any kind of functions. So as we understood, pandas convert your data into data frame, and data frame is nothing but a multi-dimensional visualization of your data. You will have it could either convert your data into series or your data frame. We are today sticking to data frame, and we'll check how this data frame is created. So first, before putting data right now, I have to create a new data frame. So I created a new data frame called as DF and used the pandas library and named that data frame as data frame and kept it empty right now. So once I have created an empty data frame, I can go into the data frame, and so like I'm going into the data frame. This command remains same. But now what I do additionally is I enter data into that data frame. So for example, how I'm putting my data? I'm putting my data in a form of a dictionary. So column 1 is the tag of that dictionary, which contains 3 elements in a list. Similarly, I have a column 2, which is again a tag of a dictionary, which has elements 4, 5, 6 as a part of a list. So what we learned about how we created dictionary, we could directly paste those dictionary inside the data frame and print the results. So now, somewhere in the backend, because pandas library store the data natively, you don't need to worry that it's gone somewhere. We have the data, and now it depends on us how we want to visualize the data. So for example, right now, I have used a command called as head. What head basically does is it prints out the first 5 rows of the data frame. So I'll do that and show you. Since we defined our variable name as data frame, we are using data frame and then the method dot head empty bracket. Once you run this, it will give you the outputs that you were expecting. So we have 3 rows, 0, 1, 2, and we have 2 columns, column 1 and column 2. Each of them have their elements as 1, 2, 3 and 4, 5, 6, as you can see. But in case I don't want to look at all the rows, what I can do it, I can just type 0 or maybe like 2 would be a better visualization. So you see, I get only 2 rows in my data. So the point is not that. The point is you can visualize your data frame by changing the numbers within the head. And if you are again playing with Excel files, you can formulate them and find out how your data looks in a data frame. So I have few more slides. I need to just confirm with Junaid. Junaid. Hi, Junaid.
Yes, Nikhil.
So I have around 10-15 slides more. So about 10 slides more, which I have to cover loops and conditional statement. So how do you, because I've extended the time, so I'm just like asking you, what should I do next? Should I like go?
I mean, it's up to you. If you find them important, like I think loops, you can go because I am going to use loops tomorrow.
Okay.
So I think loops is fine, and the rest, I mean, it's up to you.
Okay. Okay, then I can do that. Thank you, Junaid. So let me then quickly go to loops. So loops would be our last part, and then the conditional part is not that hard. I have already the slides uploaded. So let's understand another important part of Python, which is loops. So say you want to do something repeatedly, or say you want to copy a certain thing multiple times, or any such case where you want to repeat a certain activity over and over again. In these cases, loops comes quite handy. So programs give us that functionality using loops where we can automate our several tasks. And what I mean by that, I will be explaining in the next slide. So I am covering two main loops, a while loop and a for loop. So a while loop in programming. So let me explain like this. So a for loop, you can work on a limited data set. So if you have a list with a limited data set, you can apply a for loop without any condition. And what it will do is it will go into each and every element of that particular list and perform an operation that you ask your program to do. But the difference between the for and the while loop is while loop will also do the same thing. If you give the list and if you ask it to do a particular operation, it will loop through each of the elements and perform the operation. But the added functionality that while loop provides is that it could work on a very big data set, and you can define where to stop, or you can define a condition where to stop within a while loop, which is not available with the for loop. That's what I've written on the slide, that while loops have a dynamic exit conditions. You can provide wherever we provide a condition wherever you want to exit and say like, OK, I don't want to perform operation after this point in the list. Whereas when it comes to for loops, you can have a set condition, or you can provide a condition and it will loop through all the elements and perform that particular operation. It will continue running. So this is the main definition, a main difference between a for loop and a while loop. And I have again examples for that, which we'll be seeing. So loop have three different parts. They have their start, which I call, which is also called calling part. This is where you usually call the loop. In this case, for or while. So the one you see on the top is the while, the next one is the for. So you give the other part is the body. So this is where you provide the code, or you provide the condition, or you provide the operation that the task that the code has to do. And then you have an exit condition where after this condition, the looping has to stop. So for loops usually iterate over something like a list. So you have a list of numbers, it will go through each number, and once it reaches the end of that list, the loop is done, it's cut, as I said before. It can go over a set of number of times, however you want to program it, while the while loop is different. As I said, if you provide it an exit condition, it will cut and it will stop there after the condition. Again, this is something same, but I'll finish with the nesting part. So what is nesting? So you need to make decisions, you need to perform looping, and you need to perform them within each other. So nesting is nothing, but if you have a decision list or loop inside each other, or it can be crossed, this is called as nesting. For instance, if you look at this example, hello. This is a string and it has a bunch of letters in it. What the code does is it looks for a letter L. So what basically is happening is you have a variable definition, then you have a loop, then you have a decision making code, and then what output you want to print. So if you want to write codes in such fashion or in such kind of a body or such structure, this is nothing but called a nesting. It's a simple example. In this case, what it would do is you define for I in stuff. So stuff is the variable. I is the control variable that will look into the characters or the letters of that string and check where L comes. So it will go once. OK, it caught an L. It will print a value 1. And again, looping will start. It will go for a look and find another L. And it will print a value of I, again 1. So until and unless this function suffices, it will keep on looping. And when you have a decision making with it, when you nested something with it, this is nothing called but a nesting loop. So I would have an exercise which I'll go through so that you understand. So in this example of for loops, what I'm trying to do is I have created a list of words, which is nothing but strings. So here is the words. And what I'm trying to do is I want to print each and every word within a list by using a for loop. So it's very simple. You create a variable words, or create a list called as words. And now I'll just quickly, before running this code, I will explain the convention. So since we are using for loop, we are using for. The body of the for loop works in this way, is that for is a keyword that is needed when you are using for loop. Then you define a control variable. It could be anything. You can put anything. Right now, since word is similar to words, I kept as word. You can put I, you can put n, you can put anything here. In is again a keyword that means a syntax needed when you are running a for loop. And words is the variable that in which you want to run that for loop. So this is how that syntax works. So you use a for command, you use a for loop to look for words within the words uh, list and print each of those words. Now, when you run this, I forgot one thing. So let's look at the result. So we wanted to print each and every word. So what it basically does that job. It goes into the list, looks for the word. OK, it found one word, it printed. It goes again, looks another word, gets printed. Similarly, it does like that. So once you end, once there are no words, the loop automatically ends. But if there's a continuous list, it will keep performing this function, or it will keep iterating this function. A very important point which I forgot to tell was that there is an indentation format when you use a for loop. So for example, when you're using a for, you see a space here. So I'll write this so that you understand. So when you write for word in words colon, and when you hit here enter, it will automatically do that indentation. Or basically, if it's not doing, you can tab it on, click a tab on your keyboard and or 3 spaces, and you can then print that. So this is nothing but convention of using a for loop or a while loop, that it has to follow an indentation. Now this is one way of using for loop. I have another simple example. You can run this one. I have left it for you, but you can just simply run it to check, or I'll run it to see what it does. So I have again defined a variable called as words. And this time I have used a function instead of calling the variable name or calling the list. The function is range. What it does is basically goes at each and every elements and prints the words till the 7th position. So if you see, it printed the words till 7th position. This is just an example of for loop, but a much more better example so that you can distinguish between a for loop and while loop is this one. And these examples are more or less similar, but it distinguishes for loop with the while loop. So in this example, you again create a list of student numbers. It's a simple example. And what I wanted to do is I wanted to give an apple to each and every student. So there are 10 students. So I want to give 10 apples. And since I have many of apples, I'm using a for loop, and I'm trying to create I'm trying to print a sentence where the function checks inside the list the number of the student, and prints that here is an apple. So a very basic for loop. So what it does is this, the students or the control variable goes inside the list, looks for a number. If there is a number, print here's an apple. If there's another number, print here's an apple. So it does this 10 times. So if I have an infinite list and if I have a same print action, it will keep on continuously doing. But how do I control this action? If there is an infinite length of list and I want to control this action, I want to control the printing of here's an apple. This is where while loop comes very handy. So to do that, we little bit change the code. What we do is we start with one student. So we define that there is one student. And after that, we say that while or loop inside the student number until and unless you reach 20 students. Now it will follow an indentation when you hit enter, and the action remains same, that print here sorry, I missed. Here is an apple. So what basically code does is it starts from the first student, goes back into that list, checks if the number of student is less than 20. If the situation is true, it prints an apple. So, but we need to continue this until 20. We have provided a limiting condition here. In the for loop, we did not provide any condition. What we did is we just gave it a band of the numbers, and we told it that go inside the list, look for those numbers, and if you find any numbers, just print that here's an apple. But when it comes to while loop, this does not remain same. We are limiting ourselves to less than 20. And to do that, so that the loop sums every time, we are using a addition function. So what this does is whenever the loop finishes, it increments the loop by 1. So it starts with 1. You can start it with 0 also. It goes inside the function, checks if the function checks if the definition is less than 1. It says, OK, it's less than 1, then print an apple. And it keeps on summing this or adding 1 to this number and checking until and unless it reaches 20. After that, it stops functioning. So if I now run this code, it will keep on iterating until it reaches 20. So this, although I have not defined a list, but the main difference I'm trying to highlight, the main difference here is in a for loop, you can define any activity and it will perform that activity within that loop. But in a while loop, you can provide an exit condition that after that, I don't want this loop to work. And then there are different ways to edit the codes. And although I wouldn't be able to cover the conditional elements in the PPT, but it has a very simple code where I'm just trying to use a if-else condition. The condition remains very straightforward, that I have a word is called as hello. And I have defined a variable word called as hello. And within this hello, what I'm trying to look is if the word has H, if the word has a character or letter H, then it should print that first letter of this word is H. If it is not, then it should print that there is no H. So it's self-understandable that when we provide this code, since the word definition has that word H, it will give us the first letter of this word is H. If I change this to maybe A and now run the code again, it will give me no. So there's no H. So it printed there is no H at the start of this word. So I can change like the command also. There's no A in the start of this word instead of H. So conditional statements also follow an indentation just like loops. And when you write it, it follows the same pattern where you have a if command. It's similar to Excel. If somebody has used Excel, the way it works in Excel, just like the same way it works also in Python. You start with a conditional statement, define the condition right now. Here you have defined the condition where you look for the word, look in the list word for the first element, and check if it's A or it's something else. If it's A, print it's A. If it's not, print that it is not A. So this is how you define and follow indentation. So keep a note whenever you're using loops or whenever you are using conditional statements, there is an indentation that needs to be followed. If you write the code correctly, it will automatically, when you hit enter, it will automatically get indented. In case you forget, you can use tab or 3 spaces to perform that indentation. So I will leave you with this slide. So although I told most of you would be aware about GitHub, but those who are not, there is a website called as GitHub where you can get a lot of different kinds of codes, a lot of different kinds of information about tools, packages, libraries, which you can go learn for yourself and directly apply in your particular projects. One of the most common and a vibrant platform is Stack Overflow. There are several communities around different programs. If you can go ahead and look into Stack Overflow, you have separate community for data science, you have separate community for Python, you have separate communities for civil engineering domains also. For example, I work in home retrofit, so there is a particular group working on home retrofits, but mostly Stack Overflow or Stack Overflow is a part of Stack Exchange. So if you go into Stack Overflow, it's mainly you can post and get quick answers on your problems. The other main resource which you could look into is the Python wiki, where they explain each and every convention which I've been talking about: indentation, indexing, slicing, how to use conditions, all these things when running a code or getting a problem while running a code. So I hope I was able to give you a little bit of idea, although we ran out of time. But I hope you at least got a gist of using Jupyter Notebook, played with it, and tried to solve some problems. But if you have any questions, do let me know, and I would be available here for answering your questions.
Thank you.